questions 11 through 20 on the 2003 grade 10 AMC 10B. A line with slope 3 intersects a line with slope 5 at the point 10, 15. What is the distance between the y-intercepts of these two lines? So let's draw a quick diagram. So here's our XY coordinate plane, and we've got two lines, and I don't know exactly how they are, but something like this. Here's one, and here's another one like this. Okay, and our first line has a slope of 3, so it will be y equals mx plus b, where m is the slope and b is the y-intercept. So if it has a slope of 3, it will be something like this. All right, b1. Our second line, they tell us, has a slope of 5, so it will be something like this. And they also tell us that it has an intersection point right there, and that intersection point is 10, 15. So all we really have to do is plug in that value into each of these, and we'll be able to solve. So first, let's plug it into this one. When y is 15, x is 10, like that, and therefore b1 looks like 15 minus 30, which is minus 15. And then similarly, plug into that one, and we get when y is 15, x is 10. So we have 15 minus 50, which is minus 35, is b2. All right, so our equations basically become y equals 3x minus 15, and y equals 5x minus 35, like that. And then now we'll take these two guys and figure out where do they cross the x-axis. So we want this point and this point, our x-intercepts. How do we get an x-intercept? Well, you set y equal to 0. So for the first one, I'll do it down here. 0 equals 3x minus 5, and therefore, minus 15, and therefore 3x is equal to 15, x is equal to 5. So this is 5 right there. I'll do it for the second one now. Set y to 0, 0 equals 5x minus 35, 5x is equal to 35, and therefore x is equal to 7. So this is 7. And they want you to find the distance between these two. So the distance from 5 to 7 is 2. So 11, the answer is A. Al, Betty, and Claire split $1,000 among them to be invested in different ways. Each begins with a different amount. At the end of 1 year, they have a total of $1,500. Betty and Claire have both doubled their money, whereas Al has managed to lose $100. What was Al's original portion? So initially, A1 plus B1 plus C1 is $1,000. And then later, they managed to get to $1,500 among all three of them. And I'll call that A2 plus B2 plus C2. And then they give us some conditions that B2 is twice of B1. At the end of the year, they have a total of $1,500, but Betty and Claire have doubled their money. So that means C2 is equal to 2 times C1. And Al loses $100. So Al's A2 is A1 minus 100, like that. All right, so now we have to basically find Al's original portion. So we have to find A1. So where do we go from here? There's lots of things we can do. I'm going to plug everything into here because we have too many variables. So I'd like to work with just A1, B1, and C1. So since we have B2, C2, and A2 in terms of those, I'll plug them into here. So A2 becomes A1 minus 100, B2 becomes 2B1, and C2 becomes 2C1, is equal to 1,500, like that. So now we have this equation and this equation. They've got all the same variables. So hopefully we can somehow combine, manipulate, and get rid of as many as possible. Staring at this, it looks like I can probably get rid of the b's and the c's by doing the following. Multiplying the first one by 2 and then subtracting from it the second equation. So that would give me 2a1 plus 2b1 plus 2c1 minus a1 plus 100 minus 2b1 minus 2c1 is equal to 2,000 minus 1,500. Okay, so hopefully I did this right. The 2b1s cancel, the 2c1s cancel, and then 2a1 minus a1 is just a1. And then this becomes 500, but don't forget about that one. So it would be 500, but then you have to subtract the 100. So a1 is 400. And that's what they wanted you to figure out, Al's original portion. So number 12, the answer is C. Let this expression, I don't even know how to say that, denote the sum of the digits of the positive integer x. For example, is that either a club or it's a 4-leaf clover or 3-leaf clover? Well, whatever it is, I don't really know. But I'll just call it club. It looks like that club on those playing cards. So club 8 is equal to 8, and club 1, 2, 3 is equal to 1 plus 2 plus 3, which equals 6. Sum of the digits. How many 2-digit values of x is club of x equal to 3? Okay, so what they're doing this operation twice. So for example, if x was equal to, let's give a 2-digit number, anyone, 99, let's say. If you do this operation twice, oh boy, I don't even know how to write this. How do I write this? That 99 times that 99. So the first thing, of course, this guy in here, you'd add the digits. So 9 plus 9 is 18. And then you do the operation again on the 18. And then 18, the sum of the digits, 1 plus 8 is 9. So the answer is 9 for this original operation. So do you see how that happens? You're basically doing it twice. So they're saying that for how many two-digit values of x is this operation result in a 3? Well, we got a 9. They want 3s. Okay, so 2-digit, it kind of narrows it down for us. We're basically looking at all the numbers between 10 and 99 inclusive. So that helps. So let's start with a 10, and we can do this pretty quickly. So for 10, I'm just going to use a star, man. It's just easier for me. Here we go. Sum of the digits of 10 is 1 plus 0, which is 1. And then the sum of the digits of 1 is just 1. All right, that doesn't give me a 3. Let's try 11. Sum of the digits of 11 is 1 plus 1, which is 2. And then sum of the digits of 2 is just 2. All right, let's try 12. Sum of the digits of 12 is 1 plus 2, which is 3. And the sum of the digits of 3 is 3. Okay, great. I finally got one. So 12. 12 is one of them. Now, obviously, I'm not going to go through every single one from 10 to 99. It'll take forever. But one thing I did notice is that if this is 3, this will be 3. So all I have to do is figure out all the numbers that have 2 digits, and those 2 digits add up to 3. So I can quickly make a list. 12 is one of them. 21, 30. Right? What am I doing here? I'm 2-digit numbers that have a sum of the digits as 3. 39, but 39 is 12, right? So these are the sum of the digits. I'll just write that there, sum of the digits like that. So it's 3 and 3. 39, the sum of the digits is 12. But that'll work because when you do the operation again, it will be 3. You see? A little bit of trickiness there. 48 also gives you 12 and 3, 57, 12 and 3, 66, 12 and 3, 75, 12 and 3, 84, and I think one more, right? 93 is 12 and 3. So there you go. Not too long to figure this out, but if you did it 10, 11, 12, all the way up to 99, it would take forever. So how many did I get? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 9, 10, there you go. 13 is E. Given that 3 to the power of 8 times 5 to the power of 2 is a to the power of b, where both a and b are positive integers, find the smallest possible value for a plus b. All right, so let's see here. 3 to the power of 8, 5 to the power of 2 is a to the power of b, and they want the minimum value of a plus b. Okay. Oh boy. Well, I think if we were able to get, instead of all these, we got 4 different numbers here. If we can get it in this form, a to the b is equal to something to the something, right? 2 numbers. Then we can compare those. We can call this one a, and we call this one b, and then add up a plus b and see what we get. So I can probably combine these. 3 to the power of 8 is 3 to the power of 2, 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 5 to the power of 2, like that. And since the exponents are all the same, I can combine the bases like this, and then put it all to the power of 2. And then therefore, in the brackets, I've got, 9 times 9 times 5. So that's 81 times 5, which is 405. And squared. So there you go. Exactly what I wanted. 2 numbers. So that means that my a is 405 and my b here is 2. So a plus b would be 405 plus 2, which is 407. Okay? 407 is a highway in Toronto, as some of you know. Those of you that are from the greater Toronto area. Now, I'm hesitating here because is that the smallest? Can I choose D and move on here? Because it seems like a pretty big number. And I think so because I really don't see any other way of combining these two, because the exponents is only going to be a 2. I mean, it could be larger, but since we only have 1 5, I'm very limited as to what I can do. So I think this is it. 14 is D. There are 100 players in a singles tennis tournament. The tournament is single elimination, meaning that a player who loses a match is eliminated. In the first round, the strongest 28 players are given a bye, and the resulting 72 players are paired off to play. After each round, the remaining players play in the next round. The match continues until only one player remains unbeaten. The total number of matches played is. So initially, you've got these 28 players that get a bye. And what that means is that they just automatically advance to the next round. And then you've got 72 players that actually are starting. So these guys are not playing yet. These guys are. So 72 players are playing. So how many matches? I'm going to write matches here. 72 players. We got like that bracket. Some of you sports fans know exactly what this is all about, right? I'm sure you've seen these brackets for sporting competitions like that. So you've got 72 players. Each of them play each other. So there's 36 matches. All right. Now, of these 72, 36 matches, 36 will lose, 36 will win. So who advances? Just the winners. And there you go. Now, these guys advance because they got a bye, but now they're back in the tournament like that. So now, in the second round, we don't have just 36. We have 36 plus 28, which is 64. We got 64 players. 64 players, each of them will play each other, right? 64 players means 32 matches in this kind of style bracket. And then the next one, 32 win, so 32 advance, 32 lose, so 32 are eliminated. For 32 players, that means 16 matches, correct? And then very similarly, 16 will advance. That will mean 8 matches. 8 will advance 4 matches. 4 will advance 2 matches. And finally, you get the final 2. And that's your final match. And then, of course, there's a winner at the end. So now we have to add up the total number of matches. So 1 plus 2 plus 4 plus 8 plus 16 plus 32 plus 36, like that. So that's what? Total of 99 matches. And now we have to look at these answer choices. 99 is a prime number? No, it's divisible by 3. Divisible by 2? No, because it's odd. Divisible by 5? No. Divisible by 7? No. Divisible by 11? Yes. So answer for 15 is E. A restaurant offers 3 desserts and exactly twice as many appetizers as main courses. A dinner consists of an appetizer, a main course, and a dessert. What is the least number of main courses that the restaurant should offer so that the customer could have a different dinner each night in the year? Different dinner. Okay. So we've got appetizer, we've got a main course, and we've got a dessert. Correct? So let's see here, 3 desserts. So they've given you a solid numerical value for dessert. But for appetizers and main courses, they don't give you a number. They tell you that twice as many appetizers as main courses. So if the number of main courses is, say, X, appetizers is 2X. All right? And we want a different dinner, a different combination every night for 1 year. So in a year, you've got 365 nights, 365 days. And the probability for appetizer, you've got 2X. For main course, you've got X. And for dessert, you've got 3. And you multiply them, right? And that has to be greater than or equal to 365. So this becomes what? 6x squared is greater than or equal to 365. X squared, therefore, is greater than or equal to 365 divided by 60, which is a little bit over 60. 60 point something. 60.8 maybe. And therefore, if you take the square root, you'll get about 7.8. So square root. So that means X has got to be greater than 7.8. And what does X? X represents the number of main courses. So the minimum value for X is going to be 8. Because it has to be an integer, right? So let's see. If X is indeed 8, what is the number of combinations? We'll have for appetizers, main courses, and desserts. If X is 8, that means there's 8 main courses. Desserts was always 3, and appetizers would be 16. So if we do this, 16 times 8 times 3 is 384. And that definitely is enough to have a different combination of dinner every night for 1 year. So the answer is 8, which would be E. An ice cream cone consists of a sphere of vanilla ice cream and a right circular cone that has the same diameter as the sphere. If the ice cream cone melts, it will exactly fill the cone. Assume that the melted ice cream occupies 75% of the volume of the frozen ice cream. What is the ratio of the cone's height to its radius? A cone with radius r and height h has the volume of pi r squared h over 3, and a sphere with radius r has volume 4 pi r cubed divided by 3. So we've got this ice cream here, and we've got this cone. And they start off by giving you a few clues. They tell you that the radius, or the diameter rather, the diameter of that sphere and the diameter of the cone are the same. Right there. So d of the sphere is the same as d of the cone. And therefore the radiuses are the same. The radii are the same, I should say. So there you go. And what else did they say? I think that's about it. Let's write down what we want to find so we don't get confused. What is the ratio of the cone's height? So the height of the cone to its radius of the cone. Okay? So let's label that. We've got, if this is the radius, the cone's height will be right here, like that. Okay? So I'll label that there. This is the height of the cone. This is the radius. So here we go. Volume of the cone. And they've been very nice and given us the actual formulas, just in case you didn't remember. Volume of the cone is pi r squared h over 3. And the volume of the sphere is pi r cubed, and they've got this 4 over 3 in as the coefficient. Now, did they give us any values here? They don't. So just to make our lives a little bit easier, I'm just going to let r equal 1, right? There's nothing that says we can't do that. So that means this is going to be volume of the cone will be pi 1 squared height times 3, which is just pi h over 3. And the volume of the sphere will be 4 pi over 3, 1 cubed, and that's just 4 pi over 3. Okay? Now, at this point, this piece of information, melted ice cream occupies 75% of the volume of the frozen ice cream. This is the volume of the frozen ice cream. Once it melts, we have to multiply by 3/4, which is 75%. 4 pi over 3. And this, the 4's cancel, 3's cancel, and we just get pi. And this is melted right there. So the melted ice cream is only pi in terms of its volume. Okay, so far you're with me. Now the last thing is, when the ice cream melts, they tell you that it will exactly fill the cone. So that means this melted ice cream has the same volume as the volume of the cone, like that. So that means that pi h over 3 is equal to pi. Okay, exactly from the question stem. And then this equation basically gives me the pi's cancel, so I just get h is equal to 3. Yeah, that's it. And now I think we're set. We just have to go back and remember what they want us to figure out. HC over RC. Well, this is HC. I mean, you don't really need to worry about the C, but our HC was 3. Our RC, radius of the cone, well, we will let the radii equal 1, and both radii are equal to 1. So there you go. RC is 1, and therefore the ratio of height over radius is 3 over 1. And there you have it. 17 will therefore be B. What is the largest integer that is a divisor of n plus 1 times n plus 3 times n plus 5 times n plus 7 times n plus 9 for all positive even integers n? All right, so n, first of all, is even, so it's of the form 2k. So therefore, n can be, say, 2, 4, 6, 8, 10, 12. You get the idea. And therefore, this expression, for each of these, let's see what we get here. For n equals 2, it'll be 3 times 5 times 7 times 9 times 11, like that. If n is 4, we'll have 5 times 7 times 9 times 11 times 13, like that. If n is 6, you'll have 7 times 9 times 11 times 13 times 15. And you get the point. So I'll just fill all these in. All right, so here's a list of the first few n's. They're saying, what is the largest integer that is a divisor of this? So we have to look for something that's always going to appear. How about this guy, 3? Does it appear in all of these? Well, 3 is a multiple of this one for sure. It doesn't appear here, but 9 does. So that means 3 must be a multiple of this one here. 3 is going to be a multiple of that one as well because 9 appears. Again here. Here we don't have a 3, but we have a 15. That's divisible by 3. And similarly, that's divisible by 3. So 3 will definitely be a divisor of any combination of these numbers. Now let's see, what else can we find as a divisor? How about let's look at 5. 5 obviously is a divisor of that expression. It's here as well. It's not here, but 15 is, and 15 is a divisor of 5, right? And we got a 15 here, 15 here, and 15 here. So 5 also. Anything else? Let's see. 7, well, 7 is here, 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 but there's nothing here that is divisible by 7. So 7 won't work. How about 9? Well, we talked about 3 already. 9, well, we got a 9 here, 9 here, 9 here. But unfortunately, there's nothing here that's divisible by 9. By 3, yes, but not by 9. 11, let's see. 11, 11, 11, great. But unfortunately, when you get to here, there's nothing divisible by 11. So the maximum we can get is just 3 and 5. And therefore, you multiply them, and that gives you 15. And that's the largest integer that is a divisor of that expression. So 18 is D. 3 semicircles of radius 1 are constructed on diameter AB of a semicircle of radius 2. The centers of the small semicircles divide AB into 4 line segments of equal length as shown. What is the area of the shaded region that lies within the large semicircle but outside the smaller semicircles? We will need a large diagram, so I've blown this up. And let's start by creating some sort of a understanding of what we need to figure out. The first thing, of course, is we need to understand that this can be broken down into different regions. And I will draw those regions for you. So the first thing I did was complete those circles so that they both show the entire arc. And now I'm going to draw a very important triangle. This triangle is a right triangle, and it is very important to understand that it is crucial because it will help us break this into different regions. Because of the symmetry of this diagram, when you draw a line that's perpendicular like this right here, that is going to cut this base in half. Now that base, they have told you, is 1. They've drawn lines from here to here, saying that that whole distance is 2, and therefore that red region was 1. Now if that base cuts that in half, therefore this becomes a half, like that. And therefore, if that is a half, then what is this distance from here to here? Well, that's just the radius of the circle. So the radius, remember, is 1 because 2 is the diameter, and therefore this is 1. And then with Pythagoras, you can easily figure out that this height is root 3 over 2, like this. And if you remember, the ratio of the sides of a 30, 60, 90 triangle are 2 1 and root 3, like this, you will see that this triangle inside our diagram has the exact same ratios for its side lengths. 2, 1, and root 3. The only difference is that these side lengths are half of those. 1 instead of 2, half instead of 1, and root 3 over 2 instead of root 3. So therefore, this is a 60, 30, 90 triangle. All right? So that's the first part of that question. And now the region that I'm going to draw, which we will definitely need later, are the following. The first one is this region right here. This region that I have highlighted in red, right there, that is something that we will definitely need. So that is our first region, and I'll call it P. Okay? Our next region that we will need to figure out is right here. That region right there. And I will call that D. And there you have it. So we will come back to D and P a little later, but first let's start with figuring out this shaded region. So our area of the shaded region AS will be the area of the big semicircle, this whole thing right here. So pi r squared divided by 2 minus 2 small semicircles, this one and this one. So 2 times pi small r squared over 2 minus region P. That is how you figure out the area of the shaded region. So let's see what we can get with what we have so far. Our big radius for the entire big giant semicircle is 2, right? Because the entire diameter from here to here is 4. So the radius is 2. So you have 2 squared over 2. For the small semicircles, these ones, there's 2 of them that we are subtracting, and each of them has a radius of 1. And then region P, which we will figure out a little later. This basically becomes 4 pi over 2, which is 2 pi. This becomes just pi minus P. So finally we have just pi minus P as our area of the shaded region. And that's it. We have to now just concentrate on P, and we should be able to figure this out. So I'll write that up here. AS is equal to pi minus P. Now we need to concentrate on P, since that is our pending amount in terms of area. What is P basically? It is the area of a semicircle, this one right here. So that would basically be pi r squared divided by 2. Subtract from it 4 of these d's. And I hope you can see that. If this is 1d, then this would be another d, and then very similarly this would be a third d, and this would be a fourth. If you subtract 4 of those d's from the semicircle, you will get P. So now we have to concentrate on figuring out D. So it's a multiple step problem. First, let's just figure out P as far as we can. The radius of this smaller semicircle is 1. So this just becomes pi over 2 minus 4d for P. All right. Now we get to figuring out D. And I want you to pay close attention to this region right here. Look at this arc right here. This arc, or this pi segment. that pi segment contains d, but it also contains this triangle. So if I can figure out that pi segment and subtract from it this triangle, I will get d. So written out as a formula, d would basically be the pi segment minus the triangle. Now the pi segment is basically 60 degrees over 360 degrees times the area of that circle, right? That's how you figure out that pi segment. And then the triangle is just a simple 1/2 base times height. The base is 1/2, and the height is √3 over 2. And there you go. Now, what's r in this case? R is 1. So this leaves me with 1 over 6 pi 1 squared. And this is √3 over 8. And this basically just becomes pi over 6 minus √3 over 8. And there we go. We are pretty much done. We have all of our numbers. We just have to now put it together. Let's move this up a little bit. We've got d, so we can figure out p. It's going to be pi over 2 minus 4 times d. d is pi over 6 minus √3 over 8. So this becomes pi over 2 minus 4 pi over 6 plus √3 over 2. And this would be if you get a common denominator, it'll be 3 pi minus 4 pi, which is minus pi over 6 plus √3 over 2. And I will just write it as √3 over 2 minus pi over 6, like that. So now we are at our final step. Our final step was written all the way up here. Area of the shaded region is pi minus p. So here we go. Pi minus p. And what is p? It's √3 over 2 minus pi over 6. √3 over 2 minus pi over 6. And don't forget to put it in a bracket. So this becomes pi plus pi over 6 minus √3 over 2. Get a common denominator and you'll get 7 pi over 6 minus √3 over 2. 7 pi over 6 minus √3 over 2 is the answer. If you bring back the question to see the answer choices again, you will see that number 19, 7 pi over 6 minus √3 over 2, is answer choice E. In rectangle ABCD, AB equals 5, BC is 3, points F and G are on CD so that DF is 1, GC is 2, lines AF and BG intersect at E. Find the area of AEB. All right, so we have to draw a little bit of helpful labeling here. So first thing, I'm going to drop a perpendicular from E down to the bottom. That will represent our heights. And let's label a few things here. This will be H for height. This is 3, since this is 3. And then F to here, I'll label as X. And then that segment I'll label as Y. And H is just that much of the diagram. And I think that's all we need for now. If I need anything more later, I'll add. Now this region, of course, down here is 1 plus X. So just put that in there. And this region down here is 2 plus Y. Okay, so this is probably similar triangles. So here we go. Right here, this triangle and the big triangle are similar. So that means that the bases, 1 plus x as the big base over x, which is the small base, is equal to the ratio of the heights. So the big height all the way to the bottom is h plus 3. And then the height, of course, of the smaller triangle, which is just h. So that's our first one. And in a very similar way, we'll do the exact same thing on these triangles, the small one and then the very big one like that. So we have 2 plus y, which is right here, all over the small base, which is y. And then the height, we have h plus 3, all over h. And those are our initial relationships. Now, we've noticed that this is the same on both sides. So that means that this must be equal to that. So 1 plus x is equal to, over x is equal to 2 plus y over y, like that. Now, one thing you will notice from this diagram, I hope, is that x and y can be combined. You can add them. X plus y is equal to something. Now, what is it equal to? Well, the whole region from there to there is 5, correct? And therefore, this whole region is 5. Now, this is 2 and this is 1. So therefore, 5 minus 2 minus 1 will give you that much. And therefore, that means that x plus y is equal to 2. And we can isolate one for the other. Y, therefore, will be 2 minus x. This is very helpful because we can now sub that into there. So we got 1 plus x over x is equal to 2 plus y, but y is 2 minus x. And we put that in on top and bottom. And now we can cross multiply. So here we go. We've got 1 plus x times 2 minus x. And then we have x times 4 minus x, like that. Okay? Keep going here, and we've got 2 minus x plus 2x minus x squared is equal to 4x minus x squared, like that. So subtract those, the minus x squareds disappear, put everything on one side, and you'll get 3x. And therefore x is equal to 2 over 3. All right, so there you have it. Now we can take any one of these relationships right here and solve for h. So we'll go 1 over x is equal to h plus 3 over h. X is 2 over 3, so we got 1 over 2 over 3 over 2 over 3 is equal to h plus 3 over h. Let's move this up here. And then the top, of course, becomes just 3 over 3 plus 5 over 3, so that's 5 over 3, like that. And that's 2 over 3. H plus 3 over h. Invert and multiply, and you'll get 5 over 3 times 3 over 2. H plus 3 over h. This is 5 over 2. And now we can finally cross multiply. So we'll get 5h is equal to 2h plus 6. 3h is 6, and therefore h is equal to 2. And I think that's all we need to figure out the area. The area we are interested in is triangle AEB. AEB, that triangle. That triangle, basically, I think I can squeeze it in here. Area of AEB is 1/2 base times height. The base is right there, it's 5. And the height is the entire height from top to bottom, like that. So that's going to be h plus 3. H we just calculated down here as 2. So substitute that in there, and we'll get 1/2 5, 2 plus 3 And this looks like 2 plus 3 is 5. 5 times 5 is 25. So 25 over 2 is your area. And therefore, number 20, 25 over 2 is choice D.